Okay, hello to anyone watching this. So I've gone live a little bit earlier than usual. It's 10 past 9. No, sorry, 9 minutes past 10 in Denmark as I'm broadcasting this. So I've got no viewers and I'm not expecting any viewers, but I expect a few people will watch it later. This is going to be the last live session for a while because not enough people really have been watching these. So instead, what I'm going to do is try and deal with individual classes' needs more directly. So for individual classes, I'm going to arrange Zoom sessions to check in, and then I'm still going to encourage people to mail in to my school email address, jjc at, the rest of that. So if you've got any specific problems, just mail me in, and then I can make little videos explaining things, but they won't necessarily be live. Okay, so I had a request last night, somebody who was stuck on subtracting with fractions and when they're top heavy. So I'm just going to go through 4 examples of that. So I'm starting with 13 2/3 minus 4 1/2. So there's a couple of ways I could do that, and I've got a preferred way of doing it, and then I've got kind of another way of doing it. So the way I used to do these, first of all, make the fraction top heavy. So 13 2/3 I want to make into a big fraction out of 3. So 13 is the same as 39 thirds. 39 divided by 3 is 13. So 39 thirds is the same as 13. So the way I'm doing that is 3 times 13 makes 39. So 3 times 13 makes 39, but then I've got an extra 2 there. So in all, that makes 41. So 13 2/3 is equal to 41 thirds. Same thing on the bottom. So 4 1/2. 4 times 2 makes 8. So 4 is 8 halves. Then plus the extra 1 makes 9. So 4 1/2 is the same as 9 halves. So 13 2/3 minus 4 1/2 is the same as 41 over 3 minus 9 over 2 as a top heavy fraction. I bought some nice new pens today. So, and then I want to make both of these into fractions out of the same denominator. Now, 3 and 2 both go into 6, so I can make them into fractions out of 6. Oh, I got a thumbs up. Somebody is watching. How about that? Okay, so 41 over 3. I'm going to multiply that by 2 over 2 to make it 82 over 6. I'm not multiplying by 2 there. I'm multiplying by 2 over 2, which is the same as multiplying by 1. So really, I'm not multiplying by anything. I'm just, because the number's not getting any bigger or smaller, I'm just writing it in a different way. And then the same with 9 over 2. I want to make that into something over 6. So I'm going to multiply top and bottom by 3. So really I'm multiplying by 3 over 3, which is like just multiplying by 1. So 9 times 3 is 27. So 9 over 2 is the same as 27 over 6. Okay, so now that I've got them both as fractions out of 6, I can make them into one big fraction out of 6. So just subtracting the tops, 82 minus 27 is going to have to try and do that in my head, 55 over 6. 55 over 6. And then finally, I don't really like that as a top heavy fraction, so I want to write it as a mixed number. So I need to ask myself, how many 6s can I get out of 55? So 10 times 6 would be 60. That's too many, but 9 times 6 is 54. So 9 6s make 54, but I've got 55 here. So I've got 1 left over. So that's 9 1/6. Okay, so that's one way to do it. It's not actually my preferred method. So another way I could have done this is as follows. So 13 2/3 minus 4.5. I'm going to split that up into the 13 minus 4 and then the 2/3 minus 1/2. So at this stage, people often ask me, well, where did this plus come from if it's all minus? But remember, if you've got 13 2/3, it's like there's a little secret plus in there. 13 2/3 is like 13 plus 2/3. So it hasn't come from nowhere. So anyway, 13 minus 4 is 9. And then I'll leave the brackets around there. I don't really need them. And then 2/3 minus 3/2. Well, 3 and 2 both go into 6. So I'd like to make those both fractions out of 6. So to get from 2/3 to something over 6, I'm going to have to multiply by 2/2. So that becomes 4/6. And then to make a half into something out of 6, I'm going to have to multiply by 3/3. So that becomes 3/6. So that gives me 9 plus 4/6 minus 3/6 makes 1/6. 9 plus 1/6 is 9 1/6. So you might prefer one method or you might prefer the other method. I like this because it keeps the numbers low. If I'm dealing with big top-heavy fractions with the main number incorporated into the fraction, then I'm dealing with bigger numbers. But then on the other hand, doing it this way, well, it keeps the numbers lower, but then maybe it's a little less intuitive and a little less easy to understand what's going on. So I've got 4 problems today I'm going to deal with. That was number 1, and I'm going to do the remaining 3. I guess I'll do them in both ways. See, I'm going to need my calculator for this, aren't I? Because doing it the first way, the numbers can get pretty big. So let's just get calculator on there. Okay, so 6 11/12 minus 4 1/18. So first of all, if I'm going to do it the first way, I'm going to make it into 2 top-heavy fractions out of 12 and out of 18. So 6 times 12 makes 72, plus the 11 makes 83. So 6 11/12 is the same as 83/12. And then 4 1/18. So 4 times 18 is 72, plus the extra 1 makes 73. So 4 1/18 is the same as 73/18. So I've got 83/12 minus 73/18. The next thing I need to do is make those out of the same denominator. So I've got to think of a number that 12 and 18 both go into. So if I just count my 18 times table, it goes 18, 36, 36. So 12 and 18 both go into 36. So to make a fraction that's something out of 12 into a fraction that's something over 36, sorry, I'm going to have to multiply top and bottom by 3. So really I'm multiplying it by 1 because I'm multiplying it by 3/3. And then the other fraction, so to make a 73/18 into a fraction out of 36, I'm going to have to multiply top and bottom by 2. So once again, that's not getting 2 times as big because I'm really only multiplying by by 1 because I'm multiplying by 2/2, which is the same as 1. Okay, so this is where the numbers are going to start getting big. So the first fraction I want to turn into 36ths by multiplying by 3/3. So 83 times 3 is 249. So 83/12 is the same as 249/36. And then 73/18 multiplied by 2/2 is the same as 146/36. Okay, so I've converted the whole thing into fractions, both out of 36. So I can just do the subtraction on the top and leave the 36 on the bottom. So 249 minus 146, which makes 103. So that's equal to 103/36. But that's still quite horrible because it's a top-heavy fraction. So I'd like to ask myself, how many 36s can I get out of 103? So 36, 72, 108 is too many. So I can only get 2 36s out of 103. 2 36s make 72. And I've got 103. So 103 minus 72 is 31, hopefully. Yep. So I've got 31 left over. So 103/36 is the same as 2 and 31/36. Now, when I'm figuring out how many 36s can I get out of 103, you saw me count them on my fingers. 36, 72, 108 is too many. But another thing I could have done there was just do 103 divided by 36, 2 and then some left over. So I can get 2 whole 36s out of 103 and then a bit left over. So that's another way of figuring out that I can get 2. But then on the other hand, if I'm going to use the calculator, I might as well get the calculator to do the fractions in the first place, because most calculators can do that. The point of this is to learn the skill. The process is what you're trying to get out of this, rather than just the answer at the end. Okay, so 2 and 31/36 was that one. And now let's do that the other way. So 6 and 11/12 minus 4 and 1/18, I'm going to say is the same as 6 minus 4. Take the whole number bit and then add the 11/12 minus 1/18 bit, the fraction bit. Okay, so 6 minus 4 is easy, it's 2. And then 11/12 minus 1/18, I'm going to have to multiply 11/12 by 3/3 and 1/18 by 2/2. Should have left myself more space there, in order to make them into fractions, both out of 36, very much like I did over here. So 11/12 times 3/3 makes it 33/36, and 1/18 times 2/2 makes it 2/36. So that leaves me with the 2 I had, plus 33/36 minus 2/36. Leave the bottom as it is. 33 minus 2 is 31. So 2 plus 31/36, which is 2 and 31/36. Same answer as before, but 2 different ways of getting there. So advantage of this way, it's kind of easier to see what's going on, whereas this is a little more, what's the word I'm looking for? Esoteric, perhaps. But on the other hand, this way, you keep the numbers a bit lower, whereas this, I'm going up into 200s, 100s. and it can be a bit messy with the big numbers. Okie dokie. Now I'm going to do a third one. Now with the last two problems I've written here, there's a little tricky thing in that the fraction in the first one is smaller than the fraction bit that I'm taking away in the second one. So that can create a bit of a problem, but we'll look at the two ways of doing that. Okay, so I'm going to go a bit faster now. Hopefully you've kind of got the basic fundamentals of the methods. So I'm not going to spend a lot of time explaining the methods, and you can always replay the video if you need. Okay, so 13 times 2 is 26, plus 1 makes 27. So that's 27 over 2 minus 3 times 2 is 6, plus the extra 2 makes 8. 8 over 3. So that's the same as 27 over 2 minus 8 over 3. I want to make them into fractions out of the same denominator. 2 and 3 both go into 6. So I'll multiply 27 over 2 by 3 over 3, and I'll multiply 8 over 3 by 2 over 2, so that I get them both as fractions out of 6. 27 minus 3 is 81, I hope. 81 over 6 minus 8 times 2 is 16. So 81 over 6 minus 16 over 6 makes one big fraction out of 6. 81 minus 16 is 65. So that's the same as 65 over 6. 6 goes into 65 10 times to make 60, and then 5 left over, meaning I've got 10 and 5 over 6. Okay, so that's the first way of doing that. And then the second way of doing that, my preferred way of doing that, we encounter a little problem. So 13 over 2 minus 2 and 2/3. So I spot that 2 2/3 is bigger than a half. So I've got a bit of a problem there, because if I try and subtract something bigger from something smaller, I could go into minuses, and I don't want to go into minuses. So the way I deal with this is to borrow one out of the, I'll tell you what I'm going to do. I'm going to write it underneath. So that 2 and 2/3 is going to stay the same, but I'm going to borrow one out of the 13. 13 well, so 13 and a half is I might as well write it down here. 13 and a half is the same as 12 and 3/2. So I've borrowed one out of the 13 and put it into the halves. So 1 is the same as 2/2. Yep, so I've taken one out of the 13 and put it into the halves. So instead of 13 and a half, I've got 12 and 3/2. That equals that. So the reason I've done that is so that the fraction in the first number is bigger than the fraction that I'm taking away. Okay, so what am I going to do next? I am going to once again split it into the numbers minus the numbers, the whole numbers by the whole numbers, I mean 12 minus 2, and then plus the fractions, 3 over 2 minus the fractions, 3 over 2 minus 2/3. I've given myself a little bit more space this time. Okay, so 12 minus 2 is 10. That's easy. 3 over 2 minus 2 over 3. I want to make those both into fractions out of 6, because 2 and 3 both go into 6. So I'm going to have to multiply 3 over 2 by 3/3 in order to make it 9/6. And then I'm going to have to multiply 2/3 by 2 over 2 to make it into 4/6. So I've got 10 plus 9/6 minus 4/6. So that's 10 plus 5/6, which is 10 and 5/6. So once again, if I do it that way, I keep the numbers lower, but conceptually it's a little bit more difficult. If I do it this way, it's easier to understand what's going on, but you have got to deal with higher numbers, and that could be a problem for you. Okay, last one for today. So it's just another one of the same type, which I'm going to do 2 ways. I'm liking my new pens. Okay, so going to go a little bit faster this time. 20 1/4 minus 7 5/6. So I want to make those just into top heavy fractions out of 4 out of 6. 4 times 20 is 80, plus the 1 makes 81. 81. And 7 times 6 is 42, plus the 5 makes 47. So that's the same as 81/4 minus 47/6. And I'm going to make those into fractions out of the same denominator. So 4, 8, 12, both numbers go into 12. So I'm going to make them both fractions out of 12. So I want to turn 81/4 into something out of 12. So I've got to multiply by 3/3 to give me 243 out of 12. And then I want to make 47/6 into something over 12. So I've got to multiply by 2/2. And that gives me 94/12. So I've got 243/12 minus 94/12. How quickly can I do this in my head without a calculator? So it's going to be something out of 12. So 149, I hope. 149/12. And then I've got to ask myself the question, how many times does 12 go into 149? Well, 12 times 12 makes 144. So it's 12, and then I've got 5 left over to 149. So 12 and 5/12 should be the final answer. It'll be interesting to see whether I can do it the other way just as quickly and both the answers agree. Otherwise, I'm going to look a bit foolish, but we'll see. Okay, so 20 1/4 minus 7 and 5/6. So I'm going to split that up into, well, I'm not going to split it up yet because I noticed that 1/4 is smaller than 5/6. So I'm going to change that 20 1/4 into 19 5/4. Yeah, because 1 equals 4/4. So I've taken 1 out of the 20 and put it into the quarters. So that's the same as minus 7 plus the 5/4 minus 5/6. Giving myself a bit more space there because I'm going to write some stuff in those gaps. Okay, 19 minus 7 is 12. Looking good with the 12. Plus, so 5/4 and 5/6 I want to write as a single fraction, or no, I want to write as fractions out of 12, because 4 and 6 both go into 12, as I saw before. So to get 5/4 into something out of 12, I've got to multiply by 3/3. So that gives me 15/12. And to get 5/6 into something out of 12, I've got to multiply by 2/2, which gives me 10/12. So I've got 12 plus 15/12 minus 10/12 makes 5/12. 12ths. That's a word that Danes have trouble saying. 12ths. TWELFTHS. 12ths. So I've had whole classes screaming as if I was scratching my nails down the chalkboard when I've said that before. It really does some people's heads in. Okay, so 12 plus 5/12 twelfths makes 7 and 5/12. 12 and 5/12. I mean, and that agrees with my answer before, so that's all good. Okay, so hopefully that's helpful to not just the MYP one that asked me, but also anybody else. So for in future, as I said, I won't be live streaming every day, but instead I'll be trying to video conference the classes once a week at least, and then deal with individual queries. So I'll continue to put videos up, and that will be mostly explaining things from the iMaths that I've set, but they won't be live. So the only difference is that they won't be live, and hopefully that will be more helpful, because you'll get work that's more targeted to what you need, and then you won't have to sit through a load of other stuff that might not be relevant. Okay, so do mail in with your problems, JJC@theschool.